All right, here we're going to be talking about angle relationships. So when I say angle relationships, I mean how do two angles relate to each other? And we're going to use some specific words to describe those angle relationships. The first one you're going to see here, these are called adjacent angles. Adjacent angles are just angles that are right next to each other. This is the simplest one. They're just angles that are sitting right next to each other. They share a common side, they share a vertex, and they don't overlap at all. So when I say they share a common side, I mean this side, it's a part of both angle B and angle A. When I say they share a common vertex, that's this point in the middle. So they have the same vertex. That's the point where they start. They share a common side. That's that side right in the middle. And they do not overlap. So there's no overlap between A and B. They're totally separate angles. All right, the next angle relationship we're going to be talking about are vertical angles. This is similar because we're just going to be talking about like where they are in relationship to each other. Adjacent angles, there's nothing that we actually know about the angles aside from the fact that they're just next to each other, so we can call them adjacent. Vertical angles, kind of the opposite. They're going to be across from each other. So angle 2 and angle 4 here, those are vertical angles. They're on the opposite side of that X. So when you see these two lines cross, on either side, you're going to have a pair of vertical angles. Same exact thing is happening with angles 1 and 3, that angle and that angle. We can call those vertical angles. Their relationship is that they're vertical angles because they're directly across from each other. So intersecting lines form a pair of vertical angles on opposite sides of the intersection. Vertical angles are congruent. That is a mathy word for they're equal. So we can say that angle 1 is equal to or congruent to angle 3. In geometry, we're going to use this symbol to mean equal or congruent. It's basically just an equal sign with a little squiggly line on top of it. We can also say that angle 2 is congruent to angle 4 because those are vertical angles. So we know that they're the same angle. So if I said that angle 2 was 150 degrees, I would know that angle 4 is also 150 degrees. All right, these last two, we're going to actually use specific numbers to describe these angles. Complementary angles are two angles that have a sum of 90 degrees. They add up to 90 degrees. So angle B and angle A here, when we put those together, they form that right angle. They form this 90-degree angle. That's what makes them complementary. Those two angles put together form a right angle, so we can call them complementary. One really easy way to remember this, if you put a line right through the C of complementary, you see the number 90 right there. You're going to have to remember that versus supplementary, which means those two angles are going to add up to 180 degrees. So you can see angle B and angle A here. Together, they form this straight line. Angle B is this chunk of it. Angle A is the rest of it. Together, they form that completely straight line going across. The total there is 180 degrees. It's half of a circle, or 180 degrees, whereas a perfect corner like this is 90 degrees. So we're going to call angle A and angle B supplementary in this case because they add up to 180. Something kind of similar to remember this, if you put a 1 in front of the S, you can connect the two ends of the S, and then connect the ends of the U, and that's supposed to make a 180. Doesn't look perfect. Hopefully you can remember these two with their definitions. Also complementary, starts with a C, they form a corner. Supplementary starts with an S, they form a straight line. However you can remember it, it's up to you, but you need to memorize those definitions or those angle relationships, how we're going to describe how these two angles are related to each other. I'm going to do a couple of these on the back, and then I'm going to have you do the rest of them. So we're just going to shade in the relationship that we see between these angles. So I see angle A and angle B are directly across from each other. There's extra lines in here, but I'm really just concerned about this X that's formed here. These intersecting lines put these two angles directly across from each other. Those are called vertical angles. We also know that they're congruent, but that's not what we're talking about here. We just know that we call these vertical angles. On number 2, they're forming that straight line together. We have angle B, that's that slice, and then angle A completes the rest of that line. Those are called supplementary angles. They add up to 180 degrees. And number 3, we have these two angles put together to form that 90-degree angle. That angle and that angle, we can call those complementary because they add up to 90 degrees. All right, I want you to try the rest of these on your own, and then pick back up with the video on the next page. Sorry, I guess we didn't quite make it down to the next page. We're going to solve for some missing angles first. So using angle relationships, we can actually solve for a piece that's missing. If I describe these angles, this angle and this angle, and especially if I know their total or how they relate to each other, if they're congruent, then I can figure out the missing part. So I know that together, angle B, that chunk, and then this leftover slice of 23 degrees are forming that straight line, so we can call those supplementary. And really what that means is that they add up to 180 degrees. So I'm going to set up an equation. I'm going to say B plus 23 equals 180 degrees. Now, I know you might not need to set up that equation. You might know how to solve that right away, but we're going to set up some trickier examples where you're going to need to set up an equation. So here, I'm just going to solve this equation really quick with that one step of subtracting 23 from both sides. And that's going to tell me that B is 157 degrees, which makes sense. If this is 157, this is the 23 that's left over. They do add up to 180 degrees. And the next one, I see that right angle. Right away, I'm thinking complementary angles. Those two angles put together form that right angle, or 90 degrees. So they are complementary. So I can set up the equation. 37 plus B plus that leftover part has to get me up to a total of 90 degrees. And I'm going to solve this with one step, minus 37 from both sides. That tells me that B is 53 degrees. Again, that makes sense. 53 plus 37 adds up to that total of 90 degrees. All right, you try 3 and 4 on your own. And then we're going to get to a trickier example here, where we're actually going to be solving the whole equation. This is why we really need to set up the equations on the first ones, just as simple examples to get us to this. So we see angle A and angle B here. Together, they form this corner. So the type of angle relationship is complementary. They form that corner or add up to 90 degrees. So that's what we're going to set up here. We're going to set up an equation showing that these two things add up to 90 degrees. This angle plus this angle equals 90 degrees. 5x plus 1 plus 6x plus 1 equals 90. By solving that equation, I'm going to figure out the x value that makes this true, that makes those two angles actually add up to 90 degrees. So I'm going to solve for x in this step. So I'm going to combine like terms here. I'm going to put these two together, the 5x and the 6x. That would give me 11x. I'm also going to combine like terms with the constants. 1 plus 1 is 2. That still equals 90. And now I'm trying to solve the equation. So I combined all I could on this side. And now I'm going to draw the line down and actually cancel out whatever I can on this side to get x by itself. So I'm going to subtract 2 from both sides. That gives me 11x all by itself on this side and 88 left on the right side. And our last step is dividing away this multiplication. Divide by 11 on both sides, and that gives us that x is 8. Now, there's some questions where you might be done. If it's asking you to find the value of x, you're done with this question. That's not really what we're asked to do. We're trying to find the values, or I would call this the measures of angles A and B. So we actually have to figure out what does this equal. If x equals 8, what does 5x plus 1 equal? Well, 5 times 8 plus 1 is the same thing as what I'm just talking about there. I'm saying that x is 8, so I can take that value and plug it in. 5 times 8 is 40, plus 1 is 41. I can take that 8 and plug it into this one also. Or I can actually just subtract. I know they add up to 90, so I could do 90 minus 41 to figure out that B is 49. All right, last two examples I'm going to do with you is similar. You're going to set up equations and then solve for your x, and then we're going to take those values and plug them back in to figure out the actual measure of the angle. So we have these two angles, angle A and angle B here. And together, angle A and angle B, they create this straight line. So I know that they're supplementary. I can call them supplementary, and more importantly here, I can say that they add up to 180 degrees. So I can say that x plus e, this angle, plus the other angle, 2x plus 1, equals 180 degrees. And then I could solve for that x. That's going to tell me the x value that makes this true, that makes A and B add up to 180. So I'm going to combine like terms. 1x plus 2x is 3x. 8 plus 1 is 9. And that still equals 180. And then we're going to solve the equation by canceling out the adding 9 by minusing 9 on both sides. So we get just 3x by itself on that side, and 171 left on the right side. One last step, 3 times x, cancel that out. We're going to do the opposite of multiplying by dividing. So we divide by 3 on both sides, and x is going to be 57. So the value of x is 57. That's neither of those angles, it's just the value of x. You're going to take that and plug it back in for A, x plus e. So we're going to do 57 plus 8 to get that A is 65. And then you could take that 57 and plug it in there too. Or, since we know that they add up to 180 degrees, you could just subtract 180 minus the one that we know. I'm going to clean this up a little bit to make that clear. We know that this is 65. We know that they add up to 180 altogether. So you can do 180 minus this 65 to tell us that the leftover part is 115 degrees. And I want to point something out. The picture doesn't appear correct. Like, this looks like it's just over 90 degrees, maybe about 100 degrees, but it's not 115 and 65. But we're never really going to trust the picture visually. We're always going to trust the math that we use to solve. Okay, so we know that that angle is 115, whether the picture looks like it or not. One last type of equation that we can set up, we see that we have two angles that are directly across from each other. That angle and that angle are across from each other with intersecting lines like that. That means those are vertical angles and they are congruent. So they're equal to each other. This is kind of the simplest equation that we have. We know that they're equal to each other, so I could just say 4x plus 2 is equal to 82. Now I can directly just solve that equation, and I'll get x by itself by canceling out the plus 2, subtract 2 on both sides, we get 4x equals 80, and then one last step, we're going to divide away that 4, we get that x is 20. So the value of x is 20, and actually the value, or the measure of angle A, we could have solved for right away. We know that they're congruent, so this has to be 82 as well. You could take that 20 and plug it in, but you just find out that that angle is 82 degrees. All right, try the rest of these on your own. Ask for help when you need.